Good afternoon. Welcome to this session. So in this presentation, we are going to be talking about how AWS and Cognite are leveraging generative AI capabilities to transform manufacturing operations with our customers. By the way, I'm Rajesh Gamatam. I'm a Principal Solutions Architect at AWS and lead for Industrial Data Fabric. I'm joined by Petri Vanika, President for EMEA from Cognite as well. So let me first set the stage before I hand it over to Petri. So one of the common challenges which we are seeing with our industrial customers is the data pipeline scalability. Customers usually start with one use case, select a few data points or data sources to ingest, create the data pipelines. But the moment they want to scale for other use cases, it becomes a problematic issue where they have to recreate those data pipelines. So to address that, we created at AWS a framework which is called AWS Industrial Data Fabric, which is a combination of both AWS services and partner solutions to accelerate digital transformation with our customers to address this problem which I just explained. So this solution consists of 4 different regions like ingest, store, contextualize. That is the main key for addressing many different use cases. And the act part of it, from where we can consume the data with the context and address business challenges. So the main aspect is the ability to create the domain level model for the entire enterprise, wherein customers can easily scale from one use case to another just by creating a solution model out of the main domain model. Once I do it, what we basically get is an industrial knowledge graph. With an industrial knowledge graph is a powerful representation of the interrelationship between assets and processes and its interdependencies. Once we have this, that is the actual foundation for leveraging generative AI use cases, task-based orchestration, and much more use cases. So to that effect, we have the power of AWS Bedrock, as well as vector search from AWS, combined with Cognite Data Fusion's industrial knowledge graph to create a more robust RAG models, which are the foundation for leveraging all the different use cases. So once we have that, the next step is Bedrock agents. Well, now with Bedrock agents, we can orchestrate different levels of processes as a multitask orchestration system to automate manufacturing, maintenance, for example, those kinds of tasks. So each and every agent will bring its own expertise to solve a problem in terms of orchestrating the entire process. So thus, once we have this basic foundation with AWS Bedrock, AWS services, as well as Cognite Data Fusion, customers can leverage and solve many of the different generative AI use cases, such as maintenance advisor, quality advisor, engineering advisor, and much, much more. So with this, I will hand it over to Petri, who will take you through Cognite Data Fusion's capabilities and how generative AI has been helping our customers. Petri?
Thank you very much. Thank you very much. Those of you standing on the sidelines, please do take a seat, lean. It's more comfortable that way. I promise I'm not going to bite. And I'm sure you've heard and seen enough of data and AI and similarities here. So resting yourselves for a while and tuning in and listening in is going to be welcomed. So without further ado, I'll take us back to the basics, the principles. We are still with more than a decade into digital twins, into industrial IoT systems, into AI, not the generative kind, but the previous kind, which we still deploy today, by the way. We haven't lost that, and we should not lose that either. But we're still really lacking substantive cases where industrial operators, asset owners are really seeing meaningful value at scale. One could say it's kind of depressing, a decade in, and we still don't have a lot of actual evidence. There's something we need to do about it. The value pools remain: increased productivity, reducing asset failures, reducing unplanned downtime, shortening our turnarounds at our planned downtime, and of course making better decisions daily. Product quality decisions, energy consumption decisions, all decisions. So the meta remains, tons of value to be unlocked. How to get there, we're still mostly challenged. If I asked you to raise your hand if you have achieved everything you wanted over the last 5 years, I don't think I would see a single hand go up. That's probably why we're still here. But at the same time, digital is really good and nice. You see lots of shiny showcases here, lots of really impressive demos. Most of them are fake, by the way, so please do double click twice and ask how they're actually built. And ask again and again, and I can guarantee half of them are fake. Sorry, it's 90% are fake. But this is your reality. You have old assets that have gone through multiple rounds of capital projects. So it's a wild bag of different systems, different sources, different protocols. Some of these are really old. Some of them can date back a century, in refining in particular. And it's pretty messy. It's far, far, far away from what you see here on the show floors. Now, why have we spent a decade and we still haven't materially cracked the code? We still haven't really solved the business need. We haven't made it simple. We haven't made it scalable. We haven't made it cost efficient. This is a quote from a gentleman at Gartner, but since we don't have the quotation rights, I need to verbalize that only. But it's a powerful quote. Using the traditional approach is too costly. It's not that we can't solve for things. We can. It just costs too much money and takes too much time to solve for things at one asset, at one site, and then the next again and again and again. It's cost inefficient. It kills the ROI model. It'll take a decade more, and it'll cost 100 million more, and then your business case is dead. So something needs to be done. Something needs to happen. And there really isn't a good definition for what the solution is, what the new platform is. So even Gartner says there's this emerging enterprise platform that they haven't put their magical finger on and named it yet. They probably will in the next couple of years. And it needs to be much easier for people to use. And I'll come back to how these things all connect. This emerging enterprise platform, a lot of folks here are using the word industrial data operations platform, industrial AI platform. You hear contextualization all over. The first and the last, industrial data ops, Cognite, the company I work for, we invented that in 2019. Very happy that people are picking it up. Contextualization is also a keyword which we've kind of put to the market in 2019. If you go on Google and search for data contextualization, the top 7 of the top 10 are Cognite links. So very, very happy people are using it. We're very grateful for that. Makes our life a lot easier. Now again, coming back, this is still you. It's still pretty gritty and gray and complex out there. And if you take this reality, the actual field, and you turn it into the language of the data, because ultimately data is the fuel for AI, data is the fuel for optimization, data is the fuel for improved worker efficiency. If you take this and you convert it into the language of data, it looks like this. It's very diverse, very complex, and very inconsistent. What you're seeing here is exactly the same asset, a tank. You're seeing the same tank in the asset data structure, as a time series, as a file, in the form of a sequence, as a visual data representation, and in the event logs. And it's a tank. It has a tag, but even that tag is represented differently across your source systems. And this is just for one simple tank with an identifiable tag to it. And there's a lot more of these. So this is your reality. Solving for this in a programmatic, cost-efficient way is the bedrock of what we need to do and what we haven't done yet. We haven't done it yet, not well enough. We're a young company. We've been around for eight plus years roughly now. We're just getting going, just getting started. Long way to go. We wish we would have been founded 10 years earlier. We would be 10 years further now, but we weren't. So, can't change history. But solving for this at the very foundation is where it starts. And I'll roll all these backwards and forwards. You'll get the message by the time I end. Now, because the data is inconsistent, because it's siloed, because it has different naming convention, and why does this naming convention matter? A very wise man, an IBM fellow, once told me 20 years ago that, Petteri, do you know what? The biggest challenge in computer science, do you know what the biggest challenge in computer science is? It's agreeing on naming convention. If only we could agree on naming convention, all the bigger problems in computer science would be solved by now. That's the biggest problem in computer science. Now, we have the same in our assets. It's because they changed ownership 20 times. Different EPC companies came along. new systems were pulled in, old systems were thrown out, documentation changed, documentation management systems changed, document managers changed. So we're left with that whole cluster of diverse, disjointed data. Now, if I'm a shift manager and I come in and start my shift, I'm going to waste, I should say use, but I would prefer to use the word waste. I'm going to waste multiple hours of my day, every day, just trying to find what I need. If I take this into another context, I'm trying to resolve a simple trouble, do a simple troubleshooting exercise. Again, I need to go through 5 to 10 different systems, figure out what I need, print things out, put them on a wall, and then only can I start to do work. That's all waste. Now, it's really manual, it's really slow, it's really painful. And then, this being the reality, this is an AI-generated image, as I believe most here are these days. It's much cheaper, it's much faster, and it produces around about the same thing, as long as you're fine with creativity being included. If you need precision, trustworthiness, engineering sciences, and discipline, then you need to do a few more bags of tricks on AI, but there's a ways too there, and I'll end with that one. But this is the reality. You then print things out, you take the papers out, people go to the field, they look at the equipment, and they look at their papers, and they try to do something. They go back to the office with the papers, with annotations by hand. They may solve it. The next time the same thing happens, not with the same team on shift, not with the same pump, with a different pump, with a different team on shift, with a different asset, they start from scratch. So nothing that was done here got recorded anywhere. It's all wasted. It's throwaway. So, not perfect today, will not be perfect tomorrow either, but it's getting better. But we do have technology. We have much better technology today than we had 5 years ago, much better technology than we had a year ago, and it's going to be much better even in 2 years' time from now. But we can really do wonderful things today. We can actually empower people with trusted insights, conveniently, faster. We can reduce that time waste. And it is thanks to technology. I'm not selling technology for technology's sake, but technology is the only means for us to meaningfully change the way work is done today, to make our assets run smoother, more reliable, more performant, more energy efficient. Now, what does this look like? There's one example. I'm just using this example because I was talking about the troubleshooting case with people printing papers from different systems. That's kind of the, this side. I see the mirror, so it's the other way. But this is the old way. Somebody goes in, prints the things out, puts them together, goes to the field, troubleshoots, calls their colleagues, does manual annotations, tries to figure it out. Once they solve it, they dump it in the trash bin, and everything was lost. Or you can do the same in a digital surface. We call it Canvas. We borrowed the concept from Figma and Miro, who invented the canvas. Everyone now has a canvas. There's a canvas in Confluence. There's a canvas in every tool. The reason is that it's kind of a virtual whiteboard. We all learned to use whiteboards electronically during COVID-19 lockdown, so it's an easy thing to borrow. And if you ever want to introduce something new to humans, it's easier to introduce something new which they're familiar with. We don't like change. We like to tell others to change. We like to manage change, drive change, talk about change. We don't like change to touch us. That's human nature. So use concepts that people are familiar with, and then you get further faster. Now, you can do all of this. There are tools. We, for example, there may be somebody else as well, I'm not sure, where you can get all of this data brought to you by a voice conversational interface. Can you please bring me everything related to this pump? And it'll bring you everything there. Then you can collaborate. Everything is annotated automatically. The links are annotations. Every asset is connected to the files, to the time series, to the engineering documentation, specifications, work orders, everything else. All of that is done automatically. There's a knowledge graph behind the scenes. We call it an industrial knowledge graph because we only do industrial. But it's a graph technology that makes it possible in the background. Now, I'll come back to this. But this is not really revolutionary new. Putting things in context, making it easy and intuitive, and connecting different things. We all use this tool every day, at least I do, to get here this morning. It's called Google Maps. This is the same thing we do. That canvas, that was a small animated part of a canvas. It's a bigger canvas. There's an example of a root cause analysis workflow done on the canvas with agents helping you do things faster. It's really, really miniaturized. I know you can't see, but if you want a live demo, you want a expanded version, come by our booth and we'll give you the printout. Sorry, we don't do paper, but we'll give you an electronic printout. But it's possible to do. It's the same thing. Both have the same thing making it possible. Both have a graph in the background. Graph is the thing that connects the different dots, makes the unintuitive come together, allows you to navigate and see the connections. Contextualization in our vocabulary is the art and science, the technology, to automatically populate a graph. What you do with contextualization is very simple. I know I need a graph that represents my industrial reality. How on earth do I populate it effectively and in an automated way? Because if the population is not automated, it doesn't make any sense to build a graph, because before the graph is built, it's out of date, because things change every day in the field. So you need an automatic or automagic, as some customers have told us, way to populate the graph. That is what contextualization services do. So again, want to see it live, come to us, ask for a demo, ask 3 times how and why, and if we can't answer, then come and kick me and hit me on the head. Now, here. Again, graph is complicated, contextualization may sound complicated, trust me it is. I used to be the chief marketing officer of a company before I took the current role, so I'm guilty of inventing a lot of this jargon you hear here, and others are using liberally as well. Copy with pride, there's no shame in it, I copy as well. But what is contextualization? What does it mean to connect things together into a graph? The smallest little industrial knowledge graph you could have would be a graph of a pump. This example, there's a physical pump with a tag, and then all the other information that relates to that physical pump is somewhere in a system, and when you take them out and connect them in a graph and make that graph analytically queryable, so you can traverse the graph, run questions and ask and interrogate the graph, that's the most simple thing. That is a knowledge graph. But of course, a pump is tiny, asset is big, site is even bigger, so it becomes really big. Has millions of nodes and so forth. But it's not more complicated really. Physical assets and all of their documentation and data related from a variety of source systems. And here's what it looks like put into a computer system. The same example. You have a pump, has different sources of data in different shapes and formats. You put them all into one, you end up with something like, no, it doesn't work. The graph in a visual looks like that. So you have this, graph, you can navigate, you can zoom in, zoom out, move it. If you take the whole asset, it becomes a mothball. You can't see anything because there's too much. Then you have to zoom in or filter. And then as a data model, the same graph looks like that. The actual properties of every single node. You can extend them, expand them. It's fully open. We base our graph on industry standards, but it's fully open and extendable. You can also import the graph and export graph. You can also import an Excel to create the starting point of a graph. So everything is made simple, everything is fully open. Everything you see in our front ends, that canvas, is built on a publicly documented open API. You can go online, look at the API documentation. Every single thing in our software is built on open APIs, publicly documented. Also, as a unique thing, again, I used to be the CMO, every single piece of content on our website, including 3 books of 150 pages each, are available for download without any form to be filled. You can go and watch every webinar, download every book, download every content, educate yourselves without having to give us even your email address. Nothing is needed. We're an open company. Same on the product. API documentation, tutorials, videos, academy, everything is fully open. Just go and have a blast. Again, you take that and make it into something bigger, you end up with your own version of Google Maps. That's where you start. That helps you find things faster. Some say it's going to revolutionize. I think it's basics. It's baseline. That's the foundation. Then you start building valuable use cases on top. But it turns out it's a lot easier to build valuable use cases when your data is properly structured in a graph. And it gets even more valuable when you want to apply AI and you want to validate the AI's answers. Because if you anchor the AI on the graph, on your graph, you'll be able to traverse the results. And you can govern the access rights to the graph, which AI is then reading for you. Now, that was the example of the canvas without agents. This is an example of the same canvas when you activate one agent. We have many agents. We are building more agents. We will have 100 agents by June. Today, there's, I think, 24 or so. Again, agents are nothing more than little helpers. They're virtual employees that do specific tasks incredibly well. If somebody says they have a co-pilot that does everything, it's probably BS. That doesn't work today. Or it does it really poorly. But what works today is building very well-defined agents that do a narrow scope. Kind of like how we build our organizations in companies. You have a specialist in something that does something really well. But if somebody writes code really well, they rarely sell really well. So it's kind of, there are unicorns, don't get me wrong, some characters can do it all, but very few of them exist. And it's hard to build an organization or company based on those only. But when you define it, scope it down really narrowly, and you give the agent the right tooling, we build more agentic tools than we build agents. Every agent has access to 3 to 10 tools. They become really good. Next phase, next year, today it's alpha stage only, it doesn't work in production reliably, is that you have agents calling other agents, just like in organization teams, but that doesn't really work today well. I'm trying to be as honest as I can here. Individual agents work really well, agent-to-agent orchestration, sketchy. But it'll get there and it'll get really good and it'll transform things in 2 years' time. Today, we're in beta land. So what does it mean? We go from manual, people filling either static Miro boards, which is already online, but it's not connected to your data. It doesn't have access to your data. It doesn't have real-time data. Everything you saw on our canvas is real-time. You can drill down to every time it's real-time. But this is what you do today. On Miro, you do it manually as pictures, or you do it on a wall with paper printouts. You go from this to a collaborative workspace where the data is real-time. Think of it like it's a digital twin decomposed. Instead of having a digital twin in a 3D where things come, this takes out the 3D, the processes, the documents, the time series, and allows you to reassemble it anyway. Kind of like Lego blocks. And they're all connected to the graph in the background, so they know what they're connected to without you needing to ask for it. And that's why the agent can help you. If you have something on the canvas and say, agent, can you please bring all the related data? You don't even need to mention the tag name. It already knows, it's on the canvas. It'll just splash it all up. Then you can call time series agent, can you start doing analytics for me? And they will. They know what time series because it's already on the canvas. And then you can analyze. All is connected, all is double clickable, makes life easier. Yes, you can do a lot of these things today in a siloed system to a degree, but that siloed system is not connected to any other system. That siloed system, when somebody does something there, doesn't move to enrich other people's intellectual capacity. You just keep building more silos that only a few experts have access to. Now, this is a more elaborate example. There's a public case study, you can come to us and ask for it, by an offshore producer in Norway called Aker BP, where we did a root cause analysis agent that we trained and gave guidance to follow their RCA procedure. It doesn't have to be a random RCA, it can be your RCA procedure on their data, on their procedure, and in some tasks, that's a breakdown of all the tasks. There were 12 tasks in this RCA procedure. We went through every one of them and looked at how much more efficiency can we drive, and it's a ton. The intent is to go from being able to do an RCA, a proper root cause analysis, in the same time with the same cost as we do ad hoc troubleshooting today. Next stage is to have agents do it even more autonomously, so you can have it happen all the time in the background. But again, that's not today. That's tomorrow. So today there's a troubleshooting agent. There's a time series analysis agent. There's a robotics mission agent. And then there's a few dozen others. They work really well individually, can be tuned to your specific processes and requirements. They adhere to your data governance policies. They inherit the user's access rights to data, because the graph that it's calling has that user's access rights. So the agent only has access to the data you want the user to have without you need to worry at all. Now, that's a little bit of it. Couple of minutes to go, so we're well on time. And we're here I'm here to sell at least. I run the commercial function across EMEA. So I'll make a bold claim, and please hold us accountable and test us out on it. I'll make a claim that talking to Cognite is the best way to fully realize the promise of AI for industry. But it starts with building your data foundation. If it's not us, find somebody else, if there is anyone, who can help you build industrial knowledge graph and populate it automagically through what is called contextualization services in technology speak. Because that is what you'll need to get to trustworthy AI. That is what you'll need to anchor your agents in. That is what will allow you for your agents to inherit the user privileges from your different users, so you don't have to worry about them going rogue. And then as a bonus, if you're going for agents today, you'll get all of the work canvases, all of the time series analysis, you'll get everything that has been there for a couple of years as a bonus. If you want to do AI, we can deliver a lot of instant value for you well before the agents go live. If you don't want to do AI today, you need to do the rest anyway if you ever want to do AI. It's up to you how you want to position. There's a lot of people saying that by adding AI to an investment note internally, approval process goes much faster. So it's a game, play the game. But I do want to highlight that AI is the cherry on the cake today. It will be fully transformative in 2 years' time. Fully transformative. But with every single new technology, there's this little awkward adolescence phase where the expectations far exceed the reality. That's agentic AI today. Again, come test us out, put us to the test, ask 5 times why and how. And if we can't explain, then it doesn't work. And do the same with everyone else. Don't believe the demo. Ask them to open it up. One of the unique things of our agents, I'll go back to this, and you should ask the same from everyone else who has an agent. The agent is, by the way, this little agentic sidebar here, and you can call many agents. In our agents, it automatically opens up its thought process, every tool that it called. It shows every line of code that it wrote as part of that execution. And every single thing it gives you and presents to you, it gives you the exact link to the document in the graph for you to verify. If it's a longer document, it'll tell you the page number it's on, so you don't have to go through 42 pages to figure out if it was correct or not. And again, if you don't have that, then you're not going to trust it. There's no way today on this planet to make LLMs hallucination-free. Hallucinations are not a problem. They're a feature. That's why AI is so human. Because we humans, it's called imagination with humans. For some reason with AI, we call it hallucination. It's negative. It's not. It's a feature. It's like humans. You force a human to answer, they'll create some answer. AI is the same. It'll come up with an answer. The only way you can trust it is by having the tooling around and the verification built in. So you as a human can make an informed call if the AI was right or wrong. Over time, I'll make a bet. I'll take a wager here. When you have 100 times went through the whole reasoning of the AI agent and validated the data to the point of origin and said yes, when you've done it 100 times and every one of those 100 is correct, then probably the 101st time, you'll just take the agent's word for it. But you probably in engineering want 100 out of 100 before you trust it. And that's why we built all the tooling around it, because we know in engineering, nobody's going to believe the answer otherwise. I'm an engineer before I turned to the dark side on commercial. So I know. So unless I trust it, I'm not going to believe it. I'm also Finnish. Finns are much like Germans, where we don't believe things unless we can verify them ourselves. And that's kind of our market. We started with oil and gas. The risk of doing something wrong on an oil rig offshore is pretty high. It's not like people want to take guesses. It's not like draw me a picture. Oh, it's nice. I like the picture. It's not right or wrong. If I need to make a decision on turning a valve or changing a parameter, I actually need to know if it's right or wrong. So when you are thinking of applying AI, think of how do you ground it, how do you ensure validity, how do you provide auditability to it, and that will then create trust. It's kind of like doing a PhD. It's 80% about the methodology and only 20% about what the outcome is. No one actually cares about most PhD's outcome anyway. It's only the methodology. The only thing you learn going from a master's to a PhD, I'm a PhD dropout by the way, is to do methodology really well. Everything else was kind of like basic master's level, but the methodology is where it really kicks you in the butt. So that's all. I'm exactly on time.
Exactly.
I'll let you conclude.
Perfect. Thanks all. This is a very exciting presentation where, thanks to Petri, it was an engaging presentation showing the art of possible in terms of how AWS Generative AI and Cognite Data Fusion's capability is able to transform customers' operations. I think we are up for time, so we would like to welcome you all to Cognite's booth, where you will get an in-depth demo on their product.
Good. Thank you.